I decided that although the mission had lots of scientific content, to actually discuss other aspects of it, and I see I've been preceded and stuck with the title that was given to me by Forrest and Piers, which at first I didn't understand, but it immediately has come to me, and I will reveal a secret in a few minutes. Okay? I had multiple roles in Fife and Boreas, as you'll see in a moment. But one of the secrets is they snuck this little thing in here, thanks to Bob Murphy, I believe, okay, which we call Fife skis at points. And Bob actually gave me what I thought was a thrilling honor. That's EO1, incidentally. We have a whole bunch of shots of the Kanza Prairie if you guys want to do some follow-up work. Okay. But what happened was that Bob gave me this thrilling trip to get to Russia. He said, look, you know, I had a reservation on Pan Am, booked through the agency, and Bob, you told me that, no, we have a reciprocal agreement with the Soviet Union, they have to pay for some of it, that I have to go pick up a ticket somewhere in New York. You gave me an address, I went there, it was a seedy tenement, I had to go to apartment 4D to get the tickets, I got it, and I got on this Aeroflot flight, and Bob was very, benevolent in terms of saying, well, I'll give you the opportunity to do that. Well, first we stop in Labrador, get out of the plane, we're put in the duty-free shop area over there, and told that we had to stay there a couple hours until we bought some stuff. Okay, then we keep going. Okay, where do we stop? We're heading for Moscow. They said, oh, no, wait a minute. We fly down, we're in Shannon, at the, again, in the duty-free or whatever it was called. And again, we had to, got hit up. And then when we go back on, people are standing in the aisles, smoking, and it was quite an experience. I think I did manage to get on Pan Am coming home. I'm not quite sure. Okay. At any rate.
You're welcome.
Yeah, okay. Yeah, you see, he's not denying it, guys. Okay, my roles were, I was a project scientist for the FIS. I thought that was a great honor. I was not even at Goddard. I was at GIS at that time, still up in New York, with Jim Hansen. And so I basically was told that I was to be the FIS project scientist. Well, I learned very, very quickly that what was needed was to basically form some kind of barrier so that Piers didn't have to deal with Don Strebel. This is Piers and Forrest. Okay? So my initial idea was or basically direction was given to me to kind of protect these guys from that and have this role where I was a project scientist and hadn't the foggiest idea of what had to be done and had this. Well, pretty soon I was protecting these guys from Piers because I realized they had to get stuff done. And no matter how Don came on, he did the work and got the job done. Okay? I won't talk about this. We're being videotaped. Okay? But Don and Dave, they know quite well what I'm talking about here. So we'll skip over that one. Okay, my next role was to be the MAS, and for those of you who don't know what MAS is, it's the MODIS simulator, airborne simulator for the MODIS system. And this was basically Mike King's instrument. Okay, he was a MODIS scientist, chief scientist, and of the MODIS science team, and he had this MAS, which has now become Master. You may have heard of the Master instrument that's been flown around. But at any rate, he was very, very protective of this, and it was always on the ER2. And somehow Piers talked him into allowing it to go on the C-130. And then he just needed somebody to ride along with it. Now, let me tell you, this was an autonomously operated instrument, because if it's on the ER2, there's only one person who goes on the ER2, that's the pilot up front. And so he just presses a button at the beginning of the trip, and then everything else is done by it. Okay? So I basically went along to just sit on the C-130, which flew almost at the same altitude as the Twin Otter, except with one exception. It's a huge aircraft, as you all know. You just heard about it. The flight deck is very nice. It's up a flight of stairs, but inside is a little bit different, particularly with the rear door open. And there was Jim Wang at the rear door, there's something called a push broom radiometer, microwave radiometer. He was doing soil moisture measurements with that because it's sensitive to the dielectric constant of what's underneath. And he was tethered and deploying it halfway out the door. And we weren't too far back from him, okay? And so we were in there, and it was a pretty bumpy ride. And I did look at the data and so on. The trade-off for this was I had a cushy experience because I was once again selected during the '94 thing to be the Modus Airborne simulator guy, which kept me in Spokane, Washington, nice and snug and warm. And mostly I would go in and get a call from peers and saying that the weather was not convenient for a flight, and so I would just go to movies and stuff like that. It was kind of. Oh, incidentally, at one point during FIFE, a whole bunch of us, I don't know if any of you in the room remember this, we went to see a James Bond movie with a C-130, and then inexplicably to other patrons in the theater, when the C-130 opened and the tanks flew out of it, everybody just stood up and cheered and shouted. People in the theater were wondering what the hell was going on. Okay, now this is what I got paid to do, actually. I got a grant from the U.S. Army Corps of Engineers to do the soil moisture measurements by basically a dielectric probe that measured the dielectric constant of the soil. It was operated at 10 megahertz, and it directly detected the volumetric moisture from dielectric constant. I won't go into the details. I promise not to do any science, remember. So, but what happened was this was very consistent with anchoring and giving some reality to the measurements being made by the PBMR. Now, Corex, okay? Here it is. Bob, do you still remember your Russian? Is Moskva v Kursk, from Moscow to Kursk. Okay, the in situ measurement, that's what the soil moisture probe looked like. It was capable of basically non-destructive sampling. That's why it was so useful. And this is something that I was told a lot when we were there. This is nie problema. Sometimes there's a T here, it's niet problema, which basically, initially I thought meant no problem, but it really was, forget it, no solution. Not worth thinking about. Okay. During this time, I think the only person who went into this in-between thing, which was also whistle skip, was Charlie Waltall. Was in the room. Was anybody else at Kursk and all the other Boris? Not just Charlie. Charlie, do you remember when we went up in a helicopter and you were very, very nervous? You were sitting, or I was sitting on the gas tank. Forget boots and tennis shoes and so on. And the guys up front were smoking. It was driving you nuts. And then all of a sudden we're going over where are you, Charlie? I don't see, oh, okay, you switched sides, okay. You remember we flew over kind of was a river or a creek, and there were two girls down and the pilots landed. It was kind of weird.
Decided not to take data the rest of the day.
Okay. Anyway, so that was quite an experience that you subjected us to back there. Okay. Anyhow. Then the next thing in my experience at Boreas, at sensor radiance related to x and y coordinates, that's the map. You can read that yourself. I won't bother. But what it amounts to is that here I am in Spokane. This is not me. It's about as rotund as I was, but this guy is pressurized. That's why he looks quite so robust. And he bears a striking resemblance to the front of the ER-2. But that was really quite a nice little aircraft there, as you can see. Here it is, getting ready to take off, or I don't think it's just land. Here's what they call the chase car. Okay? And you see these wheels, the wings are huge, very, very large, very long, very light, and they actually, there's little skids here because they can touch the ground. This holds it above, and as it takes off, these fall off, and we retrieve them. And I actually got to do that once or twice. And there it is taking off. You see the wings are gone, but actually I think it may in this case be landing. It was an interesting flight. Okay, now, for me, how did FIFE and Boreas change my world? This is another little secret here that you guys can take with you and take some pleasure in. We heard about all the scientific results that came out of it, but just the idea of operating a field campaign and communications and all those challenges. Oh, you're looking at my little greeting here. Yeah, this was when my EO1 took off. I sent that out as my season's greeting card. It was in November of 2000, at the turn of when we're entering the new millennium. We had to do some scrambling because we were going to originally launch sometime in March or April. Things got delayed for a variety of reasons. We thought the thing was not going to last a full year even though it was supposedly an 18-month mission. So we needed to get some data. Okay? So where can we get vegetative data? It has to be in the southern hemisphere. Okay, so in the October-November time frame, I spent a lot of time in Alaska going to all these different areas. You see the hyperspectral validation sites. So while I didn't have a lot of people, well, there's the transportation. I have this time, so it won't take too much time. It's going off by itself. We had this twin otter at our disposal, supplied by the Australians. They were full participants at no cost. I'm going to go back for 1 second. I can cheat, you see. And you can notice this car has 6 different antennas. I mean, these guys were really, really marvelously equipped. And we did a lot of calibration there in the southern hemisphere, and you can see the infrastructure was there. There were maybe 100 people at least involved from Australia at no charge to NASA. And this is gratification. Okay, this is really actually all this preceded the actual launch of EO1, and there are people here. This is David Jubb. This guy's a legend, Dean Gratz, who was their field expert, and that's Ray Merton, Nicholas Coops here. You may recognize him. There's David Jupp and a number of people. All right, we had fantastic team who were selected to do the work on this thing. They were selected, and Diane Wickland's in the room. She worked effortlessly. You know, she was fantastically good in terms of getting the setup, getting everybody working together, getting complementarity. And you're reading the names as I'm talking. But what I did is I color-coded this because these guys had their own pet projects. And I'm going to go back because it's worth doing. But we were able to persuade them to go into the southern hemisphere and do the field work because we needed this as insurance that they would get their stipends if we went down very quickly, because we had no confidence that we'd go through the growing season. So we say, okay guys, just go put the stuff away. You don't have to do anything with it. You'll do your own projects. But this was the beginning of something really remarkable. If you read those names, I'm absolutely in awe of some of these. Like we had Alex Getz, who working doing his spectroscopy land base. He is the ASD person. Then you see, the first one is Greg Asner. He's here twice. We had 31 approved proposals and 30 investigators. As remarkable as it seems, he actually was awarded 2 of them. Many of these were no-cost investigations as well. So this was a phenomenal team. And I learned very, very, very quickly that my job was to basically tell them not what to do, but what was needed, and let them determine what to do to make that realization. And I conveyed that to Ghassem Azra at NASA headquarters a couple of times so that he would understand that this team had to be supported, and we had to give them what they needed to get their job done. So it was quite an experience. So here, hombre con sombrero, that's the hat. Okay, that's how I was known throughout Argentina. We attracted an enormous amount of attention. You see all the mostly press people here. And let's go on. This gets enlarged here. There's the Avarices in that twin otter. And there's Rob Green and Carlos Mojanos and myself. Here we are in Australia. This is afterward now. This is when we've already taken off doing some field work there and calibration work. This is the EO1 field campaign in Central Australia. Afterward. This is a 4,000 meter elevation in northwestern Argentina, Salar de Azaro. this is Lawrence Ong and me. All these other guys were supplied by the Argentinians at no cost again to NASA. It was a really remarkable cooperation. We had some major activities going on 2 continents, both in the Southern Hemisphere. Now, we had some unusual ways of getting data. This is one instrument that actually deployed coincident with the ONALI overpasses to look at Maricopa. This is Mike Abrams did some work in the Venice Lagoon. This place is the Institute of Hydrology. He told me that I could stay there, but I wouldn't want to because it was an old building with all this graffiti on the roof of, angels and stuff like that. Really shabby place, okay? So again, this is instrumented. Here is the Canadians. They actually wanted to sample the canopy top, and this poor guy had to lean out and clip off some of the vegetation. Now, this is an interesting one. I don't know if you heard that gunshot. Okay. Again, this is Mary Martin's group from New Hampshire. They would shoot down leaves to get at it. And I had a hell of a time getting the Canadians to work with them. The ones who were clipping the leaves. Okay, never mind. Okay, I'm finished now, pretty much. This is we're wrapping it up. This is the trying to basically keep EO1 going for a while. Through that, then I got the DoD to work with us. And then we're coming to the end here. It was a toy. I could play with it. These are all acquired by EO1. And then this is, I'll leave you with this one as the last one. Why do I wear my hat? It's really a spectral calibration standard. You don't believe it? Also, it's a very durable spectral calibration standard because it's crushable